Okay, here we go, guys. Shh, quiet, please. All right, so we're talking about the probability of disjoint and overlapping events. Hmm. Better to just not say anything then. Shh. Okay, now the first thing we're going to do is determine if two events are joint or disjoint, or I guess joint would be overlapping. So we're going to determine, are the two events disjoint or are they overlapping? And what that means is, do the two events have results that are in common? Okay, so an easy example of this, rolling a die. And we're going to say that event A is you roll an even number. And event B is you roll a number less than 3. Okay, and for each of these, and this is a regular 6-sided die, nothing special. And for each of these, we could come up with a sample space, right? Or the sample space would be 1, 2, 3, 4, 5, 6. But we could come up with what are all the numbers that fit the criteria for each one of these. Okay, so if I'm going to roll an even number, what are the possibilities for that then? Well, not what's the probability, but what are the possibilities? 2, 4, or 6, right? So I got a set of 2, 4, and 6 that I could get from that. Okay, rolling numbers that are less than 3. What are the possibilities for that? A 1 and a 2. So are these two events, rolling an even number and rolling a number less than 3, are they disjoint or are they overlapping? These are overlapping because we have a result in there that happens in both cases, right? And we could make a little Venn diagram to show this. Okay? We're going to do that. Yeah. Yeah. Trust me, you're gonna learn to love these because they're gonna help you with this stuff.
They always remind me of Bug Eyes. I don't know why.
All right. Anyway. So if the first circle represents event A and the second circle represents event B, then everything that's in this little overlapping part of the two circles would be the portion of this that is the overlapping part. So what is going to be in that little space? 2, right? Okay, and then the rest of what's in circle A would be all the other results from event A, which would be 4 and 6. And then for B, rolling a number less than 3, be the 1. Okay? So then we can use this Venn diagram to help us do some probabilities, and we'll do that later. Okay, I'll show you how to do that. Okay, but being able to take that and construct a little Venn diagram from that is going to be important so that we can use that to help us with our probabilities down the road here. So, okay, let's do, we'll do another rolling just because it's not numbers that we have to write down. So let's say that we should probably write on here this is overlapping. Okay, and the key here is it does have that little spot there where they're both. They got a number that fits both. So let's do this again. Let's say event A is So how about event A is roll an odd number and event B is roll an even number? Now we got disjoint. right? So if we were to, again, list out what are the possibilities, an odd number, you could get a 1, a 3, or a 4. If you rolled an even number, that's a 2, a 4, or a 6. There's no overlap with those. So our Venn diagram for that would have nothing in that little overlapping piece there then. So in A, we'd have the 1, the 3, and the 4. And the even number, we'd have the 2, the 4, or the 6, but nothing that they share. Okay, so this is disjoint. Okay, so that makes sense? Okay, so what we're going to do now is we're going to calculate some properties with this. Okay, so, and we're going to look at the overlapping example that we started with, and then we're going to go back and look at the disjoint example that we did as well and do probabilities for that. Okay, so you're going to want to look back at the overlapping example and see if you can tell me some of these probabilities. So, you guys can do this on your own real quick. See if you can use the Venn diagram to help you with this. First, I want to know what's the probability of just event A happening by itself. Okay? So you're rolling. So in this case, use like you're rolling the die twice. You're just rolling it once. But if you roll the die once, what's the probability that A, which was an even number, happens? That's pretty simple. Okay, write that down. And then probability of B, just by itself. Okay, then the other two, probability of A or B. So I don't care which one happens. I just want one of the two to happen. So what's the probability that that happens? And then the last one, probability of A and B. I need both to be happening at the same time. Do you see the difference between or and? Or it doesn't matter which one. I just need one or the other to happen. And both have to be happening at the same time. So see if you can calculate those four real quick. And then I'll jot them down here in just a second. We'll discuss what we came up with and how we get those numbers. It's nice of you. Yeah, I am.
Pretty good.
Mm-hmm. All right. Do you guys need any more time? We're okay? We all got something? We're not just waiting for Mr. Herrick to bail you out?
I say you should check everybody's head.
I won't be that mean. A was rolling an even number. What's that probability? 1/2. Okay. 3/6, just because it'll be easier for us to see what's going on if I do that. But it's 1/2. You're right. What's the probability of B? 2/6, or 1/3 if you were to reduce it, right? I'm just saying, for those that did, 1/3 is still right. Now, the probability of A or B, okay? So that means I want to have a number that could be even or could be less than 3. So how many numbers on a die fit the bill? There are. Okay, so let's go through them because we got a little bit of discrepancy. Does 1 work?
Yep.
Is it less than 3 or an even number? Yep. Does 2 work? Yep. Does 3 work?
No.
Nope. Does 4 work? Yep. Does 5 work?
No.
Does 6 work?
Yeah.
So how many we got? 4 out of 6, right? 6 works for that. Okay, and then what's the A and B? So I need a number that is both even and less than 3. 1/6. There's only one number that works. What's that number that works? 2. Okay. We're going to come back to those in a little bit. But does that make sense how we came up with all of those, though? Okay. Same thing. A, probability of B, A or B, and then A and B. So take a few minutes, see if you can get those 4 for the disjoint. Might actually be a little easier on this one, I don't know.
I never miss. Just so you all know that.
Mm-hmm.
Yeah.
Okay, what's the 1/2? Again, I'm going to leave it as with a 6. 3 out of 6, right? 3/6 or a half. A or B? 6 out of 6, 100%. Yep. Both happening at the same time? 0 out of 6. Okay. So, there's a relationship between these little probabilities. And we've already, like, these are straightforward, right? Just the probability A and B, that's just thinking about those events all by themselves. That's just basic probabilities, right? So those I don't think need any more explanation. A and B, both are happening at the same time. We've done actually those kind of probabilities in the past as well. It's these OR ones that are kind of the new ones. Okay. Diagram, we're thinking about the situation because this is kind of a simple situation because it's just a 6-sided die. To do, but if they get a little bit more complex, we might not be able to. So there's a little formula that we can use to get to those. Okay? So take a look at, let's start with disjoint because it's actually a little bit easier. Does anybody think that they can see a relationship between these two and then getting the OR? Yeah, right. The plus the probability of B equals the probability of A or B for that one. So I'm going to write it this way. The probability A or B equals the probability A plus the probability of B. And I'll explain in a little bit why exactly that works. Now, look at overlapping. Does that still work for overlapping? Take a look at the numbers we have for the probabilities there. How would I get that one? Yeah.
Probability of A or B equals the probability of A plus the probability of B minus the probability of A and B.
Exactly. So if it's overlapping, and in fact it works for this one too because the other one's always 0. But A or B is always these two added together, but then subtract this. Do you see that? 3/6 plus 2/6 is how many sixths? Minus 1/6, 4/6. Okay, so for overlapping, it works like this. The probability of A or B equals the probability of A, probability of B, but then minus the probability of A and B. That's kind of getting a little close there, so we'll separate those. Okay, and for point, technically it's the same formula, but your probability of A and B, if it's disjoint, is always going to be 0. Because they're disjoint, right? There's nothing in common, so there is no or there is no and, because they never go together. Okay? So those are the little formulas for doing it. So we did these little Venn diagrams, and I used those little Venn diagrams to show you why we have to subtract this little probability off of there. Okay? So I'm going to flip to the other page here, but I'm just going to do a little pictorial representation of what each of these are. So if of just A by itself, you can look at your Venn diagram, and the number of elements that you would count to use for that are all just whatever, are all the ones in circle A. A that looked to get the A by itself. Okay. That were in that overlap. Just everything that happened to be in that circle A, right? Same thing, just in the other circle then. The and B. For this one, where did we look? Just in the middle, right? Where's the overlap? Okay, so A and B, remember that implies just where do we have things where both are happening at the same time. And then A or B, where would we look for that?
Everywhere except for in the middle.
It includes the middle, actually. It's everything. So this is everything, right? Could be in one, could be in the other, could be in the overlap. It's all of it.
You can't like repeat numbers though. Looks like it was because you take that number, I guess. Tell them, Cole. Make a valid point, Cole. Caleb, Cole. Quiet now. All right.
Okay. Now, think about this in terms of area, okay? Or just the portion of it that we're using. Do you see how the probability of A or B is this one plus this one minus this one?
Yeah.
Because plus this, do you see how I'm getting this little, the overlap twice? Right? So if I do this and this minus this, that gives me this area, right? That's why we have to subtract, because we're counting those things in the middle twice if we don't subtract it away. Okay? And so it's the probability of A plus the probability of B, but we have to subtract the little piece in the middle that we've counted 2 times then, and that gives us the probability of A or B. Okay? So that's why we're doing that. So if they middle that you have to subtract, but if they're not overlapping, if they're disjoint, that doesn't matter then, right? Because there is nothing in that overlap anyway, so you don't have to really even concern yourself with it. So let's try using some of this and see if we can do some other probabilities using the formula. If you want to make a Venn diagram, that's okay. Some of these you're going to have to be drawing quite a lot of stuff in there, though, so you might want to just try and stick to the formula stuff. So, all right, so let's say let's go to a deck of cards here. So a card is randomly selected from a standard deck. 52 cards. So what is the probability that it is a 10 or a face card? Okay, so our two events, if you want to think of them that way, our two criteria, 10, face card. That's the A and the B this time around. Are those overlapping or disjoint? Definitely disjoint. You can't have a card that's a 10 and a face card at the same time, right? Okay, so we're going disjoint. So if I want to do the probability of a 10 or face card, how am I going to calculate that then? What do we use if it's disjoint? But it's disjoint, so there is no PA and B, right? So it's just probability of a 10 plus probability of a face card. And really, if I asked you guys this question like last week, you could still do this one probably. And that's what you would probably just do in your head, right? You'd start counting how many cards in the deck are both 10s and face cards. Count the 10s, count the face cards, make a probability out of 52, right? That's what you'd do. You're doing the exact same thing here, just separating them into two separate probabilities first and then adding them together. That's the same idea. So what's the probability of getting a 10? 4 out of 52. What's the probability of getting a face card? 12 out of 52. Yeah, because you got jacks, queens, and kings, right, are your face cards. And there's 4 of each, so you got 12 of them. Okay, so we got 16 out of 52. So let's get that as a percentage here real quick. What is 16 out of 52? Yeah. Okay. So because of this joint, just add the two probabilities. Nothing to subtract. You're good. Try same thing, but what is the probability of, let's say, a red card or a queen? All right. Are those two disjoint or overlapping? Those overlap, right? Because you can have a red queen. You can have two at the same time. Okay. So this is overlapping. And I want to do the probability of red or queen. So see if you can set that up while they're doing their announcements here. Oh, that's it. Maybe I should buy one now. Then, if I have the probability of a red or queen, what should I be doing? Yep, probability of a red plus the probability of a queen minus the probability of getting both. All right, well, let's calculate those probabilities then. What's the probability of red? 26 out of 52. What's the probability of a queen? How many queens? There you go. 4 queens out of a total of 52. Red and queen at the same time. 2, right? There's diamonds and there are hearts. So there are 2 red queens in the deck. So a 2 out of 52. So 26 plus 4 minus 2. 28. So 28 out of 52 would be our probability of getting a red or a queen, and that is, yeah, it should be slightly more than half. Yep. So 53.8%. So this is most of it.
How much more?
Well, there are, okay, the formulas, that's like basically it. Now, these are just real straightforward. You're searching for the probability of an OR, right? And we had formulas for that, so you could do that. Well, what if I want to know the probability of the AND? I don't know that, and I know the OR, and I know just the A and just the B, so then I can use that formula kind of backwards to go get something. We still got to do that. I'm going to do an example of that, but as soon as we're done with that, yeah, I think I'm good. So, well, let's try. Let's just see. Let's see how it goes before we think we're good. Yeah, right. Okay, so just write this down. It'll go fast. In the senior class, we've are either okay. So, do you guys see how I've given you the OR information here? 113 out of the 200 are varsity athletes, or not and, or on the honor roll. They are one or the other, but not necessarily both. Could be both, but at least one or the other. Okay. 74 seniors. That okay, so that's could be on the honor roll as well, but there are 74 period that are in varsity athletics, and there are 51 who are on the honor roll. So I want to know what if the randomly selected senior is doing both. So that's your AND, right? Both at the same time, AND. So we can calculate from the given information the probability of, let's do V and H. So we have V or H, or honor roll. We can figure out the probability of being a athlete, and we can do the probability of just being on the honor roll. Okay, all the information in there helps us do that. We can use that information then to figure out the V and H, which is what we're going for. Okay, so for a second, this situation, is this disjoint or is this overlapping? Definitely overlapping. You can be both, right? You can be a varsity athlete and you can be on the honor roll. So we're going to use the overlapping equation that we talked about, which I will jot down here. The V H in this case would be the probability of V plus the probability of H minus the probability of V and H. So we're going to use that, but we got to come up with these other three probabilities first so we can plug into that. So someone being a varsity athlete or on the honor roll. There's 113 of those out of how many? 200. And again, I would not reduce your fractions just yet. Okay, it's going to help with the addition later. What's the probability of just being a varsity athlete? 74 out of 200. And honor roll? 51 out of 200. No, because it's overlapping, so it doesn't add up exactly. Okay, good. We've got 100 equals 74 out of 200 plus 51 out of 200 minus, we'll just call it x for now, for lack of a better something to put there. Something we don't know, we call it x usually in mathematics, so okay. So we're going to solve this equation for x now. Okay, so what is 74 plus 51? 125. Okay, so what now? All of you algebra people. Okay, what's 113 minus 125? Negative 12. So we get negative 12 out of 200 equals negative x, right? So what is that probability we're searching for? 12 out of 200. And now that we've actually got to a final, we could just reduce this thing all the way. So reduce that. So the probability of and is what? 3 out of 50. So 3 out of every 50 students is both. That's what that says. So do you think that matches pretty close to what we got here?
Yeah.
3 out of about every 50 people is like National Honor Society and varsity. Think we're above that? You have more people involved with both? Yeah, maybe. Be interesting. If we had more time, maybe we could do a survey and figure it out. But anyway. So disappointed. Okay. Let's do it.